Today's demanding laser applications push lasers to the limit of their performance, requiring smaller beam sizes, better mode quality, and stable performance in medical, military, industrial processing, and scientific research and development. The internal components of a laser can change over time, causing a negative impact on your process. Accurate measurement of the laser beam profile enables the user to control the beam, ensuring delivery of the right amount of energy, distributed correctly on the target area for predictable and repeatable results. So the beam you expect is the one you deliver for medical procedures with consistent assured outcomes, industrial processes that produce higher quality and less scrap, and scientific research results that are accurate and reproducible. Ophir Spiricon is the global leader in precision laser measurement, with over 30 years of product innovation, including Ophir Optronics power meters and heads, and Spiricon beam profiling systems. While a power meter can measure laser energy and power output in joules or watts, a beam profiler measures and displays the spatial distribution of the intensity across the face of a laser beam. Precise measurements of beam characteristics are made with the profiler, including size, shape, expected intensity distribution, and beam divergence. The beam profiler takes all of the physics, science, thermodynamics, and electronics that produce a laser beam and presents 2- and 3-dimensional real-time images that are easy to understand. Historical methods of measuring a laser beam include burn papers, wall projections, fluorescent surfaces, and acrylic mode burns. These qualitative methods are not real-time and do not provide enough information about laser performance to be useful. Electromechanical methods include knife edge, scanning slit, and spinning wire instruments. These methods cannot measure pulsed lasers and can take several seconds to complete one image, ignoring transient beam fluctuations and delivering distorted images. Spiricon beam profiling systems use a camera sensor to see the entire beam up to 100 times per second. A beam profile system is placed in line with the laser beam. A sample of the beam is split off, attenuated with filters, and directed onto the sensor. The spatial intensity distribution is read from the camera, and the image is displayed and analyzed by Spiricon's beam gauge software. This YAG laser beam was used to mark medical devices. The Spiricon LBA beam profiling system displayed a deformed 2-peak beam, causing unreadable serial numbers. Adjusting the laser restored the beam to a Gaussian profile, properly focusing power and restoring quality to the process. This industrial 2 kilowatt CO2 laser beam produced 4 welding joints. The Spiricon Pyrocam 3 beam profiler showed a highly asymmetrical beam. Adjusting cavity mirrors restored the beam in less than 10 minutes, eliminating downtime, scrap, and reducing cost per part. This laser joins thin foils for data storage systems. The Spiricon LBS 300 focused spot accessory showed a Gaussian beam profile. Using the correct optics changed the beam from Gaussian to a flat top profile, drastically reducing the rejection rate. Beam Gauge, Spiricon's next-generation beam profiling software, offers several industry firsts. It combines real-time power and energy measurement with a beam profile and includes Beam Maker, a beam simulator used to train laser technicians to recognize their laser's optimal profile. From soft X-ray to terahertz, nanowatts to kilowatts, less than a micron to 3 meters, Spiricon beam profiling systems ensure success of every laser application, whether medical, military, industrial, or scientific. Call to discuss your laser application with a Spiricon sales engineer, or visit us on the web at ophirspiricon.com. Ophir Spiricon, the true measure of laser performance.